see if it's all better now. No, of course. Okay. Uh, this will be fine for now. There's going to be no... I guess I can just add noise suppression in OBS over my mic. It should be fine. There we go. Everything's fine. All is well. So what were you saying about Nitro? What were you trying to ask? The... I've... Yeah, it's always just been pink. I've never had the newer Nitro. I've been on Nitro Classic still. Also, what just happened was the noise suppression that I had was not being happy with me. I just made OBS use my mic directly and then applied the noise suppression filter, which is the same noise suppression I'm using anyways, through OBS, and it's fine. All is well, hopefully. Let's see. Okay, so as I said while I was muted before, since I should probably say it again, I did not fix the editor being super bright or set up any hotkey to use the editor from elsewhere since last stream, but I did make it slightly opaque, so it should be slightly less obnoxiously bright. It's still a bit blinding, but I hope that relatively it shouldn't be as bad. And now it was being real difficult trying to get something set up to work with that, and so okay. So how I want to start out is I actually want to slightly refactor something that we did last stream. Yeah, I did not mean to open a new file. So what I want to do is I want to implement these functions, which I defined up here. So I'm just going to copy down the definitions. And yeah, do this. Okay. I can't really do this for matrices. I can't do the get version with matrices because I can't return a matrice. I can only return native data types. Or matrix rather, sorry. I can only return native data types, so these are all that are really going to get it. But that's fine. That should be fine. Everything should be fine. They mean things to me. Internal... No, not internal. It was byte mem. Pointer plus offset. And really, it should be basically this easy with all of these. Return Byte mem. Yes. Uh, the memory of bytes. Bool mem. Printer bus offset. Fixed mem. Now, this is kind of repetitive, but also I think that it's probably still the best way to do it, even if it is kind of repetitive. Mem pointer. Pointer is just a integer. It's just for a bit of clarity. These are not, these two things are not of meaningfully different types. Return string mem pointer plus offset. There we go. And then down here, it's going to be real simple. Again, byte mem pointer plus offset equals val. Oh, add. Well, since this is very tedious work anyways, the fact that I have an add probably does not matter for me doing it. And yes, I could just let people, or have people, myself really, just modify the memory directly in function, but I think that this makes it a bit clearer how to do it and prevents any accidental like math issues a bit better. At least by separating the pointer from the offset. So clearly. Right. Fixed. Mem. I do not have a fan on. Does it sound like I have a fan on? Do I need to go back and check my stream again? Everything sounds fine. I think. Fixed mem. No, there's nothing that's loud enough to cause that. There's nothing that was loud enough to cause an issue with the noise suppression. I think it's just because I was muted for so long that it didn't like the fact that I was suddenly making noise because it was the actual mic itself that was muted. So even the noise suppression thing wasn't getting any noise. So it was like, ah, there's suddenly noise. This must be noise. Sometimes. Pointer plus offset equals val. And then finally, strings. String mem, pointer plus offset equals val. Cool. Add get and set functions for the native memory types. Should only be used for natives. No. Only for natives? I don't want to make the line too long. It's complaining at me that I'm making the line too long, so only for natives. Okay. Add get and set functions only for natives. Yes. Okay. Yeah. So these are native types, which means that they're C types basically. What it really just means is that they're types that are not being made by me. So matrix would be a type that is not native, and thus I cannot have a function that returns a matrix here. Me ages ago? You've been a mod here since 2019, probably, is my best guess. At the very least. It has been a very long time since I have streamed. Well, except for Saturday, because so it's actually only been 2 days since I streamed, you know? So now that I have that down, I think I can actually start working on the neural network itself. And I still don't think that there's a good way to like include matrix in here, whilst also being able to include it in the main file. So I'm just going to include it up here. Well, I guess I could just not include matrix here and include it in the neural network file instead. But I think I'm just going to make sure that I include maybe no. I don't think this is a super good way about of doing this. Technically I could include it in like a sub thing here, right? But then it would still have the chance of being already defined. Yeah, I'm just gonna press forward. I really wish that I could do like if not deaf, right? But I don't think I can. I don't think I have any, any compiler macros because it hasn't actually been compiled. I could go look. If in deaf equivalent galaxies. I don't think anyone would ever. Yeah, no. Wait, there was one. I didn't really want to go there, but okay. I don't think that this is a. Yeah, this is like some weird crypto thing, I think. Okay. If not death indeed. If not death indeed. Where was I? Cool. So, I need to now implement the actual neural network. This is going to be a struct, and then I want to do type def struct ref neural network. Neural network. This is just so that I can kind of pass it into functions and stuff. What's the issue here? Oh, right, I need a semicolon here. Never think to put semicolons after blocks, honestly. Struct neural network. Okay. So in this, I need a pointer. Should I make it like, should I do like fixed pointer, right? Just for clarity over in the memory bit. I think I will. Pointer fixed. I think that this is silly. Yeah, I figured I couldn't do that. Then I can technically just be like, yeah, let's do byte pointer, bool pointer, fixed, int, string, bool, int, and string. These are all the exact same thing. These are all just integers, but I think that it adds a bit of clarity. So I can just be over here. I can say, okay, well, I want a, what is it? I want a int pointer for structure. I want a I don't think I can do a function ref. That's going to be kind of tricky. So I'd like a function ref array, like type thing over here, but I think that a function ref needs to be defined, basically. It needs to have a template defined, and I don't really want to do that. I don't think I can make a generic function ref in Galaxyscript really in any meaningful way. Because I wish that it could have a dynamically sized, or I wish that it could have a not compile time array sized of function refs for activation functions here. Though what I could do is I could make an activation function thing and then give it its own. Yeah, I'll just have to do that. I'll have to make a like activation function struct and then make a memory allocator for that instead. Yeah, that should work. Cool. Um, then down here, uh, I'm gonna comment this out, but this will need to be implemented. Because I want to be able to define a different activation function for each layer in theory, right? Then int pointer. What else do I need? So I need structure. Actually, don't need another int pointer though. I want a matrix pointer. And over here, I'm gonna have to. I guess I'll put this like here. Pointer as matrix pointer. I'll put this up here. Okay, I should technically split it off from this. Okay. Pointer, pointer. I want to, now that I added the pointer types, this will just be a generic pointer, but I can now do byte pointer, bool pointer, fixed pointer, int pointer, and by the way, Chainsy, if you're still here, so is my Discord actually showing me as uh streaming today, or is it still not doing that? Because I promise on my screen it is currently showing me as streaming. Interesting. Cool. It probably stopped because I did technically stop streaming for a brief period, so. Byte pointer, bool pointer. No, maybe these should be renamed to pointer end instead, or something like that, instead of end pointer, but I'm fine with this, honestly. Byte pointer, bool pointer, fixed pointer, int pointer, and string pointer. Cool. Byte pointer. Eh. I can technically just do this instead of, well, if I can spell, I can just do that. Fixed. Don't need to actually be using my mouse here. This might be a bit unnecessary again, but I think that adds a bit of clarity to what I'm doing. No, I cannot spell. And string. Cool. And then I need to come back up here. Oh, okay. This is fine. Doot, doot. And I think I can just do that. Bool pointer. Fixed pointer. Boop. 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 Int pointer. Boop. 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 And string pointer. Boop. 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 Cool. Now everything looks fine. I'm gonna do a bit more aligning of this again, just because I think it looks nice when that is done. uh, this is just me being a bit silly. Admittedly. 2, 1, 2, 3. Cool. Mind me just doing a bit more aligning. Looks snazzy. Scroll down, scroll down, scroll up. It looks like everything in here is good. I'm gonna comment this out for now. Wait, no, I don't need to. Weights and matrix pointer biases. Cool. And then over here, I think somewhere. Everything looks fine. But now I want to go to anywhere that I'm using fixed min. Since I implemented that. But I also want to commit this. I should not forget to do that. So I'd already had those set by, yeah. Add specific pointer types or clarity. all still int. That's pointer types for clarity, still int. Commit. Cool. Then I pop over here. Get fixed. So m.data. That looks right, I think. Oh, I wanted to replace that with that. Set fixed m.data mat at m.calls row call func row call. Then I need a semicolon here. What's wrong? Oh. Aha. So I think I'm actually even going to make, instead of doing this, instead of using get fixed everywhere, matrix, add matrix, pointer type for clarity, still pointer. Oh, no. Wait, I do have a stage change. Oh. Okay. So I think I actually want to do mat get fixed point. Int x, int row, int call, matrix r m, int row, int call. Fixed mat set matrix rm, int row, int call. Because these are kind of the same level of helper function as the metat. Now this does technically have a bit of, no, okay, cool. Since I'm doing mat here instead of this, okay, cool. I'm doing smart things. Though I don't want to return a fixed with set. I want to return a void with set. Now, under here, mat at, I want to add these two as well. And then set should not typically, no. It really depends on the game. If I'm feeling a bit more, like if it's a bit more just like gamey game for me, or if it's a bit more like, yes, I'm enjoying playing like I guess whether I'm playing the game for the gameplay or for like kind of any roleplay aspects. It's get underscore get fixed. Get fixed. No. This is set fixed. Of m dot data. Then the offset is mat at m dot calls row call. And then I want to set it to, I need the val, which should be fixed val. Yeah. Val. Okay, then I want to go up to here, and you need a val as well. Your type is fixed. Cool. And then down here, they'll just have to freeze. They will just have to freeze chains. Get fixed. m.data. Meta recall. There is a need for any of that there. Cool. And then anywhere that there is a fixed mem being used in this file should be changed to mat get. Then I can just m row call I'm gonna make sure each function still works after testing it, so after changing it, so yeah, I am really mean. Print still seems to work. Mat set m row call func mat get row call. Oh, this needs to have m pushed past n too. And I forgot a comma here, I think. Yes. Semicolon. See, I feel like this is just a lot clearer than this, I think. It could still probably be a bit clearer by having like a stand-in variable here, but I don't care that much, honestly. Fixed mem. It might technically be better to just leave this as is. I could do a like plus equals minus equals. Because I'll need 2 function calls here to replicate this. Oh, no, I'll need... Yeah, I'm gonna leave this as it is because I'm just looping over the bit of the data. I guess I could use set fixed and get fixed here instead, but... Yeah, I'll use set fixed and get fixed here. m.data m.data. The offset is I. m.data I plus scalar. I think this is how I'm going to do this here. This might be slightly more convoluted than this, but I'd prefer to avoid actually just outright using the, the memory array here. Minus other.data I. Okay, set fixed. There's an add, fun, delightful even. I have to let Twitch play ads though, otherwise Twitch will give pre-roll ads, which are painful to everyone involved. Nobody likes pre-roll ads. Let's see. Okay, set fix, get fixed, cool. Everything looks fine there. Sum plus equals. I'm just gonna copy this line. Yeah. So either you have to run ads, like let Twitch run ads actively, or you have to, you shouldn't, Twitch should have pre-roll ads turned off because I'm letting it run ads. Like it really, really should, that should be a thing that it's doing. If you let Twitch run ads, it should not play an ad when you join a stream. They do be double dipping, apparently. Yeah, if you let Twitch play a 1 minute, 30-second ad every 30 minutes, it should not show pre-rolls to new viewers. Not get. Do. Let's see. I call? I think this is what I needed. Voice. Being a hack. I think that this should be right, but then nah, it's fine. Output data. Being a hack indeed. That set. Sometimes your voice just be a hack. Output row call sum. That should work. Then I can get rid of this. You are a hack 24/7 or? Looks to be working. Do I put it through a matrix calculator again, or do I just trust that it's working? I think I put it through a matrix calculator again. So I'm going to screenshot this. Then I'm going to bring this over with me. matrix calculator. Matrix multiplication calculator. There we go. I think this is a no. These should be the dimensions of these matrices. O.0813, and then O.8579 and O.2654. Letting someone else check my work for me. Oh, gosh darn it. How did I write it the first time? Apparently. O1. No. You become O1. Last stream, I thought that I made a mistake somewhere and that it needed fixing, but now I realize I did not make a mistake anywhere. Nothing needed fixing. O1. O. M. And then over here, I want to change this to M and O. Okay. Now, pop over here, do this. Oh, I do, however, want to do logging matrix. No, over here in main, I think. I want to do that dot rows, other dot calls. Okay. This looks to be working fine now. I'm going to check to make sure that this math is actually right. Oops. Close you. Okay, calculation. No, I want to do, never mind. Okay. O.75053. O.6453. And then over here, O.1060 and O.3728. What can I calculate? Is that matrices? Do I need to do this again? Okay. O.6453. I really just want to make sure that this is working right before I move on. O.1060 and O.3152. That is very wrong, but maybe I did it wrong. Did I ever put in a number wrong? Yes, I did. That's 3728. But I can't. I'm on screen. What is this? Okay, let's try this again. Let's try this one last time. I think that it's working right though. 53. O.6453. 1060. O.3728. Okay. Now, yes. 31523. Or so these are technically rounded to this place right here. this place is technically rounded, so I think that the difference between this and here is probably just an issue with the fact that they were rounding. I'm gonna consider that to be the case. Or the fact that these are really imprecise. Cool. So then add map get and map set to avoid manual memory or manual access of manual mem access. Heck yeah. And I'm not using fixed mem anywhere. Am I using get fixed anywhere besides there? Yeah, but these functions, I think it's okay for the scalar functions. Just because I am going across the data array. Oh, no. I guess A. Since I did technically change that with this, I will do that. Okay. Now I have everything ready to start actually working on what I wanted to work on. So, what I wanted to work on today was, should I make the activation function stuff into a separate file, or should I just put it at the top of this struct activation? Will be a func ref fixed x. Can I do this? No? Okay. Type def activation function. Then over here, I want to make it, no, activation template. Then fixed. So, should I specify that it doesn't have an implementation? No, implement. Cool. This works. Fixed. Actually, should I just make it an apply function instead? Apply mat apply sample. Should I just use the mat apply sample here? Yes, I will. Activation or no function, and then graph derivative. Oh, I might not actually be able to have graph fields in a struct. I think it's going to complain to me about that, isn't it? It's going to be all like, you can't have graph fields in a struct. No. Did I include this? Yes, interesting. Well, I'm gonna pretend that I'm sure that this will work. Type def, activation, or Starcraft. Activation, or... And then I can kind of just pop up here and be like, kind of copy a lot of this work. But instead of matrix, I want it to be activation. Oh, these last two actually want to be all caps. Cool. Oh, free activation and alloc activation, I guess. That is a problem. Pointer. You should be taking, you should be returning matrix pointers and freeing matrix pointers. Um, update alloc matrix and free matrix types. Then I did that. Down here. Boop, boop. Copy this. Do this. And then over here, do I actually have the implementation anywhere? I do. Okay. I like not matrix though, but and then in here, this should be internal. Activation. Oh, okay. That all works fine. Everything looking neato. And then down here, actually want to be using activation. And over here, matrix and matrix. Update more pointer types. It's not going to give me any errors for these pointer things because technically speaking, they're all ints. Now, am I using matrix anywhere? Matrix mem. I do not want to be touching matrix mem. I want to be touching activation mem. And I think that using the do we not have an activation mem? Oh, I'm so good at this. But you definitely exist. This is a problem that apparently exists in that file. What's your problem? Oh, no, matrix free. A dot function equals null. And then I want to copy you because well, everything's fine here now. I do want to pop over here though because I discovered another technically bug. It shouldn't really matter too much. Actually, this one might matter because the chunk size is different. Is there anywhere else I'm using? Okay, no. Fix chunk size. Or no, fix wrong constants being used in matrix mem size. Okay. Now over here, I wish to I think I guess make an activation new function, right? So I did this over here. I think the most important thing with what I'm doing here is that I'm internally consistent. So I did this over here was I did this, and then I did a separator, and then I started with that. So now I should I called it init over here. No, I called it Alec, but that's because I think I'm gonna call it init over here. Activation init is a void function that will take an activation function, a function bug graph, and a bug graph to match apply sample, and then you are function and derivative. And then I'm gonna call you A here. A dot function equals function. A dot derivative equals derivative. Technically, I could just do this in multiple lines in the other file, but I am choosing to do this like this here, and then yeah, I'm just gonna leave this like this. I have the freeing. Now I can just take a activation pointer, activations, and structure size. Because this is something I very much need to actively keep track of here. I don't have any other way to get it. While doing things. So for now I'm going to avoid doing any of this like memory stuff with the neural network, just because I don't think I should immediately need it at the very least. So I'm gonna jump straight into what functions I'm gonna need. I'm gonna need nn void nn alec rather, sorry. Also need a free function, that's right. And everything else should be basically just the implementation, right? Void nn underscore get weight and neural network R again, and then int layer, I guess is what I'll call it. Void and then get bias. Neural network R and N and layer. And this actually should not be a void. Matrix pointer. I can't return the matrix, but I can return a pointer to the matrix. Which can then just be used to get matrix. Right. Maybe I should call these like get bias pointer then instead. Right. Just that it's clear that I'm not actually returning it in the name instead of just the typing. Activation pointer. And then get activation pointer. Neural network R and N into layer. I guess maybe I should do index instead of layer here. But is this meaningful doing these? Because realistically, anywhere that I'm going to need the weights, I'm also going to be like, yeah, I think it will, because then I won't have to reference the weights. Biases. No, I'm not doing this. This is dumb. If I could actually return the matrices and activation functions here, it'd be cool. But since I can only return the native types, I don't see any real reason to do this. And their ads, delightful. For now, I think I'll just implement the locate and free function then. I know I'll need more. What will I need? I will definitely need at least a feed forward. Oh, I should also make just an outputs. Outputs. And then I think I'm gonna not have a underscore here. I'm gonna leave it as just feed forward. And I want a matrix pointer here. Or no, matrix R here. Doesn't need to be a pointer. Inputs. I made a typo. Okay. Inputs, input. I'll take inputs. No, I should take an input here. Void train. Matrix R. Oh, I also need to take the neural network itself. Right. But I'll need to take that in all of these functions. Inputs, outputs. Matrix reference, or maybe I should do this like expected outputs. Expected. And then in feed forward, I'm also going to need to take the neural network and of course up here as well. And now feed forward, train. I will start implementing the allocation. Getting the last activation here is gonna be, or the last output here is gonna be annoying. So maybe I'm gonna return a matrix pointer here to the output that you'll be expecting. It's been a while since I've streamed, except Saturday, because I didn't didn't stream Saturday, or I did stream Saturday. Sorry, it's been a while since I streamed, except Saturday. There we go. Stream Saturday. Haven't streamed for like months before then. That's what I mean to say. I can word. I can English. Neural network R. So then I also want to take in here a int pointer structure. And before I take in the structure, I want to take in an int struct for length. My hope is that I will be streaming every day except Sundays at like 8ish. We'll see if I follow through with that, but that's my plan currently. Trying to get back into this whole streaming thing. So we'll see. We'll see how that goes, but it should be that. That's the naming convention I'm going with. int pointer structure. So then int I equals 0, int I equals 0, I less than. Well, I'm glad you have enjoyed my streams. Is structure length. I do want to do an n dot structure size. Struct size equals structure length. I don't know why I did this the way I did. I'll do len at the very least. I plus plus? No plus plus in Galaxyscript, right? It's plus equals. This language is certainly something. So I also need to then do n dot weights equals alec mat Yeah, I need to allocate struct len. What's the problem here? Do I not have an alloc? Oh, matrix. I actually did the full name there. Okay. Allocate matrix. And what do you take? You take account? Okay, I have that now. I think that this is right. I might need technically one less than the structure length, right? Because inputs, the outputs won't need one, right? So it'll be one less than the structure length. And then dot biases, alloc matrix, length minus 1, and an n dot. For now, I think, do I want to just like, okay, right. So I think int, or no, activation pointer activations. Then I can just add this up here too, I think. Maybe, we'll see. Okay, okay, alloc activation. Structure length. Oh, but do I want to be doing this? Because technically I could just set those things to my... As long as I don't change the... No, I won't do that. So my thought was that as long as I don't change the activation, technically, it's fine. Right? As long as I don't change the activation function, I don't need to copy it. but I do think I would like to copy it. So maybe I'll make that a function up here. Void copy activation copy. Oh, I don't actually want to do the implementation here, and I should have I should have this here too. I'm gonna put the init activation R from activation R2. So then I take a to and a from reference, and then down here. What am I doing? These should be up above. So these should be like here. There we go. And then void activation copy from from and to. And then 2 dot function equals from dot function and 2 dot derivative equals from dot derivative. I'll also need a matrix copy at some point, probably, maybe. We'll see. And doing that will just be, it'll be a very similar process. I'll just have to loop over the data and copy it. So I guess I should do that now, since I'm anticipating that I might need that. I'm gonna do that now. I think I'm gonna put it right after free. Void map copy matrix R from matrix R to void mat copy matrix R from matrix R2 2 dot calls equals from dot calls, 2 dot rows equals from dot rows. And 2 dot size equals from dot size. And then for, I also need an int I up here. For I equals 0, I less than 2 dot size, I plus equals 1, 2 dot data, no, mat set, mat get this will actually be fixed set and fixed get. Fix set or set fixed? Yeah, set fixed. Data 2 dot data I, And then get fixed from dot data I. Cool. Add copy function. Over here, I wish to did I already do the, yeah, I did do the copy function. Okay. And I also want to do outputs here. Alec matrix. Structure links. So I want the input layer and then all the other layers. Cool. Technically I can just set the data pointer to get certain things. I kind of have some ideas for things I can do. For example, if I want to over here, I'm probably going to want the ability to get a row of the matrix. So I'll put this up here because it's kind of a I'll do rows. Matrix RM. Matrix R output. And then just because I have to give it an output matrix because I can't return a matrix here. Lovely, lovely experience working in Galaxyscript. So I take the matrix, take the output, and I want the row number as well as the count of the number of rows that I want. And I'm putting this under the copy function, I think, yeah. Void mat row. And I'm just gonna copy this actually, where is it? Rows. Cool. Then I do this. Entropy, row pointer, m.data plus row times m.calls. And then output dot calls equals m.calls. Output dot rows equals m dot rows. So if output data is 0, it could mean two things. Do I want to assume that you are not passing in a matrix here that hasn't been freed, or do I want to just free it? Do I want to just be like, okay, let's just free this? Oh no. This also just doesn't free the Free at the beginning. Okay. I don't want this to be m.rows, I want this to be count, actually. And then output dot size equals output dot call output of rows times output dot calls, and output dot data equals. I don't actually need this to be at the top. Don't know I had that at the top, honestly, apparently. Because I want to start at the pointer. And then I want to go, so the row that I want it to be, to start at. I guess maybe I should call this start instead of row. The row that I wanted to start at. So like if it's row 1, then I want to jump forward that many points of data. Okay. And I also do want to do an error here if start less count greater than m dot rows. I want to return, but I want to do error, display error. That's what it was. Then I want to be like error in mat rows start plus attempt to access outside bounds, maybe. Start should be I guess since I'm gonna do this, I should also say, do I want to trust that they will not give me a start that's less than 0? That I will not give myself a start that's less than 0? Or start, no, I don't. Or count, no. Because the count, okay, that might cause some weird behavior, but technically it's a different error and I don't really want to deal with it. It'd just be setting the rows to a negative number. And I guess the size to a negative number due to that. That definitely caused some weird behavior, but implement mat rows to get specific rows of a matrix. Not specific, just to get rows from a matrix. No copy. That's fine. No, I don't want to say. Commit. No copy. It's no copy. Nope, wrong line. Do add comments to clarify that rows doesn't copy. Okay, and then you might technically be able to. No. I want to make it so you can copy from yourself into yourself, though. So, because I want you to be able to make a copy of yourself, though that could cause memory leaks unless you are. I also want to make sure that I never free the Demeros. Okay, this should be fine. Gonna be an experience. Nat underscore mem. Matrix mem. nn dot weights. So I guess I want to mat alec. Matrix mem. nn dot weights. We'll do this. Matrix R. No, matrix. Just matrix. Weights. Matrix biases. Matrix. Not biases. Weight, bias, and output. Though I shouldn't actually need an output one here because that's not what I wanted to do. The output should just need to be allocated. So it should be the last structure length, then this structure length, right? I think so. This is gonna be something. Let's see. Let me go get something to reference really quick. I know what I am doing. I have done it recently, even. Me having done it recently doesn't actually mean I know what I'm doing, though. Okay, yeah. You're what I wanted to open. I just do not super want to get things wrong right now. So yeah, it should be the current structure plus it should be the current structure then the structure plus one. So get int structure I get int structure I plus one. Int struct car int equals no int struct next. Just so I don't have to keep going to get it. structure I next equals get int structure I plus 1. Structure next. And then weight equals matrix mem and then dot weights. The plus I. Bias, no, bias equals, what's wrong here? Ah, type of matrix is not assignable to matrix. Does that need to be, okay, cool. Love it. Love that type matrix is not assignable to matrix. And then dot biases plus I. Okay. Now I just need to actually do the initialization of the weight. So weight matrix mat alec weight. Structure current. I would like you to be struct underscore current and struct underscore next. Let's see. And weights or biases, I think, should technically start at 1. So then there should be 1 struct. But is it struct current or struct next? Okay, mat alec bias 1 next. Okay. I think this is right, and then I want to I should get the random function, the fill random function from over here, and just toss it up in here. You know what? Since it's a function I expect I'll be needing a lot, like in theory. No, no, I'll do it. Technically, it's a kind of util function, so I don't know where it should live. I guess I could just make a util. File, right? So new file util.galaxy. Pop it in here. And then import that before everything else. But then should I put the logging in there too? I should put the logging in there. Hey, Alchemy. How you doing? Then boop boop. Where display message? That's good. Will not work. Copy this line. I feel like these have kind of thematic distinctions here, so I'm gonna do that, and then logging over here. I want to get rid of this one, change this one, and do this. Fill, yeah, fill logging. Right? No. Move logging, logging. Eh, I can type move logging, add, move, fill, random. Boop. And then over here, I can do mat. That's good. Mat apply. Wait, fill random. And over here, I can do mat apply bias. Fill. Do I want to fill the bias with random, or do I want to? I think so. I think I'm supposed to fill with random. Cool, cool. Oh, but I could do matrix random and then give it like a between value over here, right? That might be kind of neat to be able to switch out what I'm filling with randoms between. Because technically I should be filling it with a... I'm not tired at all, you're tired. Technically I should be filling it with a random between -1 and 1 for the weight, right? I'm gonna I'll put it right next to apply. Mat rand and not in fixed min fixed max, because that's what, or does this take min max min? Let's see. Yeah, this takes min max. Okay. Apply. I'm actually going to be a lot closer to copying this, despite the fact that it's okay. Let's see. Random fixed min max. Oh, not rand. Min max. And then I do actually need to take in the matrix as well. Not rand. Okay, there we go. And then here, instead of doing that, I can do mat rand 0 and 1 bias 0 and 1. And over here, I can do mat rand weight -1 1. Right. And now, in theory, I should be doing that. Cool. Matt Ellick, Matt Rand. And then I think, in theory, that's everything. Oh, no, I need to, no, I already did the output. Okay, that's everything I need for the feed forward function. So matrix pointer feed forward. Neural network R and N matrix R input. Oh. What? What? Oh, okay, the issue is that it doesn't have a return statement. Cool. Return 0. Return -1. That should never happen, but okay. Oh, but I could also just like pass in an output here, right? Like I could pass in a and then just overwrite the output and then make it a void function. Then just output put dot so I want to copy that into the output, maybe? Yeah, I think so. I think I'll just n dot outputs. N dot no. And this is fun to do, I guess. No, I don't want this here. Okay. So I want to start off with actually doing the setting of the output here, I think. So and then matrix copy. Not copy. And then no. Matrix mem. Yes. So I want to copy the nn dot outputs plus nn dot struct length to the output. Okay. This should work in theory, at least in returning an output. Now I need to actually do the feed forward logic, which actually should be pretty simple, I think. Feeding forward should just be int I equals 0. Let's see. if input dot calls not equals int get int. I do have the structure, right? Cool. In dot structure. Do I want to just keep this pointer and hope that it? Yeah, there's no reason to for the person that passes it in to free it, so it should be fine. So if it isn't equivalent to the first of that, then I want to return an error. I'm gonna just return, admittedly. And I want to do output error. What did I call you? Display error. Error. In forward. It's input not of correct dimensions. Input dimensions wrong. So if the calls aren't that, or input dot rows not equals 1, I think I'd like to make sure that it's just that, I think. Though I guess maybe I don't necessarily want the rows to be just 1, because then maybe, like, if the rows are multiple, right, then it could make sense for something like a recurrent neural network if I want to do anything like that. Text processing would be a pretty easy way to go with this. Well, I think it would be easier than trying to import like another data set proper. Like just doing a little bit of text processing on my own would be easier than like importing like a handwritten digit data set or like MNIST or something, right? Not that it'd be making anything good either way, but input dimension wrong. Okay. Then I want to set the in dot. So I think what I can do is I can just set the data for the matrix mem in dot data. No, not dot data. Dot outputs. Right, because this is the first matrix here. Dot data equals the input dot data. And then as long as I don't mutate this, which I shouldn't be actually mutating this itself, it should be fine. Because I don't want to mangle the input, but I don't want to copy the input if I don't have to. You know? Then int I. So I am going to need the integer I, but I think I'm also going to want a matrix reference to the weight to the individual output that I'm at right now. Per output cur current and bias current. And then technically I do also want the activation. Okay, and then I should now just be able to do I equals 0, I less than this dot, or not this, nn dot structure, minus 1. I plus equals 1. That's wrong, though. Struct lin. Please tell me I didn't do that anywhere else. No. This is the first place I could have done that. Mat dot. So I want to do the dot product between the output and the weights. So yeah. I think I'll also need output next. Output next. Right. And then so I guess I should weight current, not weigh current. Weight current equals matrix mem nn dot weights plus I. Output current equals going matrix mem nn dot outputs plus I. Bias, no, all capitals, equals matrix mem nn dot biases plus I. Yeah, there we go. And then output next equals matrix mem nn dot outputs plus I plus 1. What? Okay, I have no idea what the problem was there, but it looks like it's working fine now. So we shall see. Now what I think I want to do is We shall see. Matrix. Mat dot. And then output current. Weights current. Weight current. And then output next. Mat add. Element. I need an element add. Element add. Element sub. I'll just replace you with element add. Matrix sub. Error in matrix sub. Mat element sub. Error in mat element add. Error in mat element add. There we go. And do that. That all looks good. Add match random. Add that element. Add. I'm gonna pop over here. And mat element add. I think I'll put next, and bias current is what I want to do. And then I apply the activation function. Right, so then that is output next. Activation mem. Activations plus I. Oh, dot function. Okay. And that all looks like it should work now. Apologies for the chair being squeak. In theory, I should be able to do this, and then this. Then train, no, input expected. The result is actually technically a thing that I am going to want to, so. Then, and then print, not in print, map print result. And what I want to do there is let's see. And in Alec. So then neural network and in int structure. So I want to make it a Structure length. Ads are delightful. Love you, Twitch. So great. Such a great experience. Int. Not int. So I think I'm just gonna make it 3 for now. Right. And then int pointer pointer and structure struct pointer and pointer and int pointer activation pointer. Or not int pointer, activation pointer, activation pointer. And then I want to no. Technically I can do equals alec struct. No, alec int 3. Alec activation 2. And then activation mem activation pointer plus 2 plus 1 equals. I have to make 2 new activation functions here. Activation, or I could just do sigmoid on both. I really only want the output to be sigmoid. I want the middle to be nothing. No. Fixed sigmoid equals fixed none do nothing. Now let's call you none. Fixed none. I'm very good at this whole programming thing, promise. Val, intro and call, return val, fixed val, intro and call. Sigmoid. No, how do you implement sigmoid again? Right, I should actually look this up on the spawner. Sigmoid implementation. Do you have it? 1 divided by 1 plus XP. 1 return 1 divided by 1 plus. Can I easily do sigmoid in this? Let's see, math. So it's just POW, right? So POWF? Okay, just POW. POW val -1. Or no. 1 minus val? E. E is... E is probably a constant. I assume E is 1, right? No? What is E? E is the base of the natural... Okay, you always remember right. I don't... Look, listen. I am not here to be smart. I am here to write code. And listen. Number... Okay. I don't think I have a constant for that. No, probably not. Um, constant E. Not int, fixed. Then I'll just copy paste this a few times. It's not like it'll actually go out to that precision anyways, so like equals activation. Activation 2. You can tell me that's uninitialized, right? What? Do I have to like to make it a reference somehow? So do I have to do like struct ref? Oh, right. No, actually, okay, cool. That's actually nice-ish for now. So then activation init. I'm gonna want sigmoid derivative here too. Minus val. And sigmoid derivative is I need this later. Is the function multiplied by 1 minus sigmoid? Sigmoid multiplied by 1 minus sigmoid. Fixed. N equals sigmoid val. Okay, maybe I'm not going to pass it over there. So the sigmoid function n times 1 minus n yeah, so it is sigmoid times written as e what sigmoid. Okay, I'll just accept this now. I again am not smart enough for this. Okay. There's a bit of repetition here, but it's because I don't really want to call the function with row and call here. And I want to set this to none, none. And alec. Oh, right, I also need to set the struct. So set int. Struct pointer 0, 2. Copy this a couple times. Because then this should be 1, and this should be 2, and I want you to be 1, but I want you to be 2. Cool. And then struct pointer and activation pointer. Cool. And then map parent result. So then I want to feed forward. Score feed forward. I also need a row, technically. Matrix, input, row. Mat, rows, input row, 0, 1. And then I want to mat print input row. And then I want to actually set mat, right? So int x and y. Technically, I could manually set this, but I think I'm going to be a bit lazy and not do that. For x equals 0, x less than 1, x plus equals 1. It'll probably end up in a similar code size, honestly. For y equals 0, y less than 1, y plus equals 1. And then input dot set So with each one of these, so I guess maybe I should just like do a quick int input int at I as well. Because then I think I want to make I equals 0 here. But I can't do that. I'll set I equals 0 here. And then in here, after each one, I'll do I plus equals 1. Mat set input I 0 x mat set input I 1 y, and then mat set output I 0 x XOR y. And then roughly, I think this should do a nice little XOR. Yeah, looks good. And then I want to print that. So see if there are any errors so far and print that if there are not. Line 162 of matrix. Nope, that's not what I wanted. One 61. Int min, int max. Okay, void mat rand. Oh, fixed. Fix type in mat rand, but parameters. There we go. Now that's done. That's what I was expecting. But what if I go to, so row 0 was a bad row, right? Maybe I should just loop over all the rows and output them. So like for I equals 0, I less than input. No, I less than 4, I plus equals 1. Then do this. And then I can just do boop. Now, theoretically, it should do. That's not what I was expecting. And I'm not sure if this is an error in mat rows or an error in how I'm setting things up here. Right. Because technically these are fixed. What if I make you fixed? Oh, I'm not sure if you're going to want to XOR a fixed with a fixed. We'll see. One.0. Is this going to work? Oh, lovely. I am so not a fan of this. Okay. Now will you do anything? Okay. Confused. I think he's referring to the wrong line entirely. I think I'm just going to do int to fixed, right? Yeah, like so. And then like so. Now, will this work? Okay. It didn't give me an error. I want to do output display debug. Debug. Int to string x. A plus boop plus int to string y plus int to string x up y. There we go. Oh, plus. Now this should let me see the. Oh, less than 2. That was a silly mistake to make, honestly. Let's try again. That. So it looks like everything is working. Everything is being set. Do I need the int to fix here? Or is it willing to implicitly convert this? Is it willing to implicitly convert an int to a fixed? It is. Heck yeah. Okay. And then input, result. And I do also want to make sure that the inputs don't get changed at all. Oh no. Okay. Attempted initialize ref in mat apply. Attempted to use an uninitialized reference. Now, what do we think that means? That means either that we tried to use an uninitialized matrix, or that we tried to use an uninitialized activation. Which are we thinking it is? Oh, actually, maybe that's the issue. No. So I don't really like the way that it displays errors here, honestly. Especially since it is displaying them behind the debug. Invalid output matrix supplied. Okay. Invalid output matrix supplied. Error in mat dot. I do want to actually clarify where those errors are. So invalid output matrix supplied. Invalid output matrix. So I guess that means that the output matrix are being made wrong. Should be this. Is that what I did wrong? I kind of doubt it, but I'll check just in case. Did I forget you? I did forget you. That's the problem. Structure links. And then get int struct. No, structure. What is it? Structure, yeah. Links -2. And get int structure length -1. I think that this is right now. But then also, these maybe need to be swapped around, is what I'm seeing. Then I don't actually need to do the leave for this one. The Starcraft editor sometimes likes to make you leave invalid matrix dungeons. Yeah. Funk is null. No. Debug. Display error. Funk. Error and that apply. Funk was initialized, I think. I think that's how I'd check for that. And then return. Otherwise, if m matrix. Nah, I feel like I'm gonna trust that my matrix was initialized. But having an uninitialized function genuinely is vaguely threatening. Let's see. So it should be null, right? I don't know how to check if this is uninitialized, honestly. Well, I'm just gonna leave it alone for now. And I'm seeing that it's saying uninitialized function ref, so that means that it should be something to do with the way that I have my activation function thing done here. Oh, I should need... Okay. The answer is I'm silly and didn't even actually acknowledge them. So I should be able to just move that right there. And now... invalid matrix dimensions, okay? But then... down here and this... is that the issue? Boop. Invalid matrix dimensions again. Um... Output next should be... So I want to do the dot product between the current one, the current output, and the current weight. And I want that to be put into output next. Then I want output next to be oh no. No, that doesn't make any sense. I want output next to have bias current added to it. And then I want that to have the activation function applied to it. So in the dot product function, the dimensions are wrong. Okay. And if I fix the dimensions here, which I honestly think that this is the right dimensions. I think that I was right initially. Was an error in the add function now? No. Technically, I just didn't change it fully though this time. Is it going to be an error in the add function now? Yeah. So then if I do pop up here and do comma space 1, then I do this. We'll see. We'll see. Still wrong. Was that him? Will that make it, or will, I guess, probably this, hopefully? Okay, if this makes it work, then I think I have another error in my dot. No, it can't be an error in my dot product function. That all checked out. Okay, so the outputs, right? Should be initialized as the weight should be the current structure, comma next structure. The no, those obviously should be randomized. The bias should be 1, comma current structure. And oh, the output should be 1, comma. Okay. I'm smart. I don't know where I got what I got from. Honestly. Don't know how I got to the conclusion that what I was doing was right. But invalid matrix dimensions and add. Oh, this should actually technically be struct next, shouldn't it? Okay, now does this work? Invalid matrix dimensions. I'm confused. Metallic bias 1. Is that it? I don't think that's it, though. There really shouldn't be. If that's it, I think, yeah, okay. Invalid matrix dimensions. I think it should be struct next, and it should be one struct next. As far as I'm aware. Looking at another implementation I have done recently-ish. This is sort of me porting something somewhere else. Just a wee little bit. Uh, I'm confused. I guess it must be somewhere down in here in the feed forward function, right? The issue. So I do the multiplication between that. Then I add a bias current to that. Can I map print output next and bias current? Okay, now over here in main, I am printing something I want to not. I want to not do any of the main printing. So maybe it's an issue with how I'm getting structure next. And structure up here. Oh, that could be a part of the problem. Technically, do not think I meant to be going that far. Okay. That shouldn't actually have been the problem, though. I don't think. I'm really confused. add the bias to that. So I'm printing the bias. What is the output current, maybe? Maybe that's... Oh, did I mix up output current and output next? Plus I plus 1, no? They're all 0, 0. Maybe the -1 here is wrong. But that shouldn't be. Yeah, no. Over here in main, I am giving you 2, 2, 1. I'm allocating 3 ents, and the ents are 2, 2, 1. I do not have even the slightest clue. Debug print? No. Display debug. Message area chat. Get int structure struct pointer. Wait a second. No? Oh, okay, yeah. 0, 0. Sorry. And I want to wrap this in an int2 string. This 1 and 2. I want to check to make sure that these are actually 1 or 2, 2, 1. Yeah. Okay. So then print. I'm doing the printing down there, but then up here I want to do display debug struct current plus boop. And I want to wrap you in a int2 string. Int2 string. That there. Two, two, 2, 1. Yeah, that's correct. So then the biases should be 2 and then 1, which is accurate. The output should be, I think I have the outputs right? And I am doing output next here, right? So I ends at structure.length. So this should be -1. So let's try this again. What are you gonna give me? So then output next, output current, and bias current. Output current, output next, bias current. Bias current is 0.6. The output next is the wrong one though, isn't it? But why is it wrong? How are you wrong? The output's I. I wish that I got like proper errors and stuff. Well, I do not believe I have the brain power for this right now, honestly. I have not been streaming as long as I'd like to entirely, but I think I might call it for today. I'll chill on the screen. Thank anyone who is here for coming. Thank everyone who was watching the VOD for whatever reason. That's what's called, right? I think so. Thank you everyone who was watching the video of it, this stream, for doing that. Again, for whatever reason you're doing it. I hope you have enjoyed your time here to at least some extent. Yeah. Next time will try to figure out what the actual issue with this is, and then maybe, hopefully, the feeding forward part will be done so I can start implementing actual training of the network. Bye.